Now the question says they might travel from tau x for tau y at an average speed of 50 km per hour. Alright? And then at the same time Peter left tau y for tau x opposite direction, traveling at an average speed of 70 km per hour. If the two taus were 600 km apart, alright? And then how many hours did it take from the starting time for the two to meet? Now assuming that they met at this point, why I make it slightly more than tau x is because we know that Peter was traveling faster than Mike. Okay, so it's more to x. Because given the same amount of time, Peter will have traveled longer because he was faster. So we let the time be when they met for Mike be d1 over 50 km per hour. Same goes to for Peter, but for Peter now I straightaway equates. The distance travelled by Peter is longer. How much longer? We take 600 minus away the distance covered by Mike over speed. His speed was 70 km per hour. And these two time is equal because they met at the same time, so I equate them. So now we have d1 over 50 km per hour is equal to 600 minus d1 over 70 km per hour. Alright? Cross multiply, we have 70 d1 is equal to 3000 km minus 50 d1. Alright? Reshuffle it, we have 120 d1 is equal to 3000 km. Therefore, d1 is 3000 divided by 120, which is 25 km. What is this d1? This d1 is the distance covered by Mike to the point he met with Peter. So, what is the time taken for that? It's 25 km divided by the speed, which is 50 km per hour. That worked out to be 0.5 hour, which is half an hour. Alright, that's when they met from the starting time. Thank you for using Playmaths.com.